Good, crisis averted. So, function whose graph forms a straight line is a, someone take a guess what goes in there.
A linear function.
Yes, linear function. So who remembers what functions are? Does it ring a bell at all, at least? Sort of. Cody's searching for something.
A function is a type of relation where x, where each x value domain can be paired with one y value range.
Right. So, I can get to the right page. There we go. So functions are any kind of graph where if you pick any x value, you'll only see one y value paired with it, given whatever its length. So, if you guys would want to turn to page 230 in your book, which some of you have already done, which is great. For the check it out, which is near the bottom of the page.
So 1 right?
230. Alright, so it tells us to identify whether each graph represents a function. That's our first thing we have to do. And explain if it is or isn't or why. And then the second part, if the graph does represent a function, is it linear? So, 1a for that check it out thing. Does that represent a function?
Yes.
Yes? Why?
Because every x only has one y value.
Does everyone agree with that? Whatever x value you pick for that, it'll only give you one y value. I take the silence as a yes again. So, yes, it is a function. Because each x value, that's bad, because each x value is paired with only one y value. Alright, so we did the first part. We identified if it represents a function and explained why. So, if it is a function, which we already said it is it linear? So,
Yes.
why?
Because it's a straight line.
It's a straight line, exactly. So, it is a function, and it's a linear function because exactly what Cody just said, it's a straight line. So, the function is linear. Linear because it's a straight line. It is linear. Because it's a straight line. I cannot write today. It is a straight line. And that graph kind of looks something like that, right? Yep. Alright, so we did 1A. So someone tell me 1B. Abby, can you tell me what 1B is? Is it a function? No? Okay, so for 1B, no, you're doing good. So what was the first thing you said?
They all have the same
Right, they all have the same y value. So if you pick any x value, so let's go with 2. what value will you get? Okay, does it have any other y values with it? Okay, so what would that tell us then? Yes, it is a function, exactly. So even though it's a horizontal straight line and every x value is getting the same y value, so like Abby just said, they're all getting the same y value, so no matter what x value you pick, it'll all get the 4 or 3 or whatever number you said, so yes, it is a function. Today. Because I really need to write better. Because each x value is paired with only one y value.
And we always end a sentence with punctuation. I went up and added it above. I do not let them write without proper English structure. Sorry.
No, it's fine. All right, so we did the first part for this one. We said it's a function, so is it linear?
Yes,
And that's because,
it's a straight line.
exactly. The function is linear because it's a straight line. All right. All right, so now we're on to number 1C. And that graph kind of looks something like that, right? A sideways U. So, what do we have to do? We have to identify the function, right? Yep. So Aurora, is it a function? Why? Okay. Could you give me an example of something that, like if you pick an x value, what are the y values that comes with it? If there are things like that. Mm-hmm. It's not a function. It's not a function. So what were your points again when x equals 4? Okay, when x equals 4, what does y equal?
Y equals 2.
Exactly, so, extend the page. When x equals 4, y equals 2 and negative 2, you said?
Yeah.
And negative 2. So that right there, if we have one x value and we get two y values, that automatically tells us that it's not a function. So that's exactly right. Do we have to do the second part for this? Identify if it's linear, or a linear function, excuse me.
Yes, because it says, is it linear? After it says, explain if the graph does not represent a function, is it linear?
Say that again. What does it say?
It says,
Tell us
if
to
the
do.
graph does not represent a function, is it linear?
Are you reading that right?
Oh, I thought we were using the.
Oh, nope. We're just looking at the, check it out in the book right
Right there, it's written right, he's just not reading.
Oh,
now. Okay.
Right hand quoting.
if the graph does not represent a function, is it linear? Is that better?
No, there's no not in there. If the graph does represent a function, there's no not in there.
All right, so. Is everyone good so far? Everyone knows functions and identifying them and whatnot, so. Last question, are all straight lines a linear function?
No.
What do you mean?
Well, if you have your line going up and down straight like this, it's not a linear function.
So something like that? How would I actually use a straight line? Like that? And why would that not be a function?
Because say your x value, your line is on 2. Well, when x equals 2, it can equal -1
Mhm.
and -2, or it can equal +1 or +2.
Exactly, so Cody's right. The answer would be no. Oops. No. The reason is because a vertical line, I cannot write today. A vertical line even though it's straight, so is a straight line, is a straight line. But the same x value has many different y values. X value. Does that make sense to everyone? When we have a vertical line, like Cody said, it's an x equals something, so if it's x equals 3, we have a lot of y values that compare to it, right? Because x is only 3, we have a vertical line, so there's infinite number of points on that line. Alright, does anyone have any questions about this yet? No? Alright. If you want to turn to the back side, will be to determine if the table of values, so instead of just looking at a graph, you'll be given a table of x values in one column and y values in the other. So to determine if the table of values is a linear function, there has to be a constant change in x that corresponds to a constant change in y. So for this practice problem, Joss?
Can I just say how
Sure.
as x increases, y decreases?
Okay, you can put that increases. Y decreases. That's one way to put it. So when we go from -2 to -1 in our x, what are we doing? Adding 1 plus 1. Go from -1 to 0. Adding 1 and same thing for the last one, right? So what are we doing for the y's, Julia? As we go down, what are we doing? Right, so 9 to 6, we subtract 3. 6 to 3, we subtract 3, and the last one, subtract 3. So, is there a constant change in the x value? Yes. Is there a constant change in the y value? Yes. So that means that this is a linear function.
Okay, but we can't just say as x increases.
Mm-hmm. Yep, even though that is technically right, Joss, you were right on that.
You should, you could have left that there. Increases by what? As x increases by 1.
There we go. Increases by 1. Y decreases by 3.
The decreases takes care of the negative, not just.
All right. Does this kind of look familiar? So if we're just looking at the x part, does that going down look familiar? We just did stuff like that with arithmetic sequences, right? So, would this be an arithmetic sequence at x column
Yes.
with the y value, or
Yes.
y column, excuse me? Yep. So, if you ever get a little stuck, that could be a helpful way to remember to get linear functions. So,
So do we still need to finish this though? Is it a linear function or not then? Yes or no? Is it, yes, it is a linear function or no, it is not?
Yes, it is linear.
okay, so since there is a constant change in x and a constant change in y, it said, which this tells us, which means it is a linear function.
Wait, what tells you that? What tells you that?
When there's a constant change in x, that corresponds to a constant change in y, so since this,
Constant is just by the same number.
yep, so just like we were doing with arithmetic sequences, that there has to be a common difference between each term. Since there's a constant difference between each value in our x column and a constant common difference between each value in our y column, that tells us that it's a linear function. Function. All right. Is everyone good with this so far? Excuse me. All right, last thing for our notes today, we'll be determining if a set of ordered pairs is a linear function. So, last thing we just did, they already gave us a table, right, with all our x values and stuff put in there already, so. Good Lord. Here, we're given ordered pairs, so we have to write in a table and check the change in x, and the change in, someone take a guess. Y, exactly. All right, so what should our first, or where should our first ordered pair go in this table? Not at the top, right? So -4, 13, they go right next to each other. What's the next one? -2, 1, 0, -3. And the next two, 2, 1, 4, 13. Exactly. So, Tori, what are we doing in the x column? If we go from -4 to -2, what are we doing?
Subtracting 2,
Subtracting?
adding.
Right. So we're add 2. And the next one, adding 2. Next one, adding 2, and the last one, we're probably going to add 2. Right, so now we're on to our y column. So,
-12,
-12, yep.
-4,
Mm-hmm.
+4,
+4,
and +12.
+12. So, is there a constant change in the x? Yep, we're adding 2 to each new value. Is there a constant change in the y? No, we're going all over the place on here, aren't we? So, since there's not a constant change in x that corresponds with a constant change in y, which means that since one of them is not changing constantly, is this a function? No. Oop, don't write that. Okay. So there is not a constant oops, change in y, that's not f, that corresponds to a constant change in x. All right, so are we done yet? Is this good enough for any question that you guys might come across?
No,
No? Why?
because you didn't say if it's linear function.
Exactly. And is it?
No.
Nope, it is not. So therefore, this is not a linear function. Not a linear function.
So if it has a constant change, if that is going to be a linear function on both sides?
Yes, if there's a constant change for your x and your y, then it is a linear function. If you just one of them doesn't have a constant change, then it's not a linear function. Good question. So, does anyone have any questions, concerns about anything? No?
I do. What should they show in their homework?
Well, you should show in your homework. Oops. When you're given a graph like we did in the check it out problem, it'll ask you to identify if it's a linear or if it's a function. If it is, you explain why. Then if it is a function, you explain if it's linear or not, or identify if it's linear.
What if it isn't a function? Don't you have to explain that?
Mm-hmm.
Okay, so either way, you have to explain whether it is or isn't a function and why,
Yes.
okay?
Okay. And if it is a function, you have to identify if it's linear. And you'll have to explain that, which would probably just be something like it's a straight line, or if it's not a straight line. All right, then the next part, you're dealing with problems that give you tables and ordered pairs. So what I expect is you show the constant or the changes between each value, so like the +1 and the -3.
So they should be making the table on the paper, correct?
Yes. Yep, and then when you're given ordered pairs, they won't give you a table, so I expect you to make your own. And just like with problems where they actually give you a table, do the same thing there. Then once you get all your changes in between the values, you're going to write things where either there is a constant change in x that corresponds to a constant change in y, and you're going to say by how much, so like +2, -1, things like that. And then the last part is identifying if it's a linear function. All right, so does anyone have any questions about what you're supposed to do on your homework? Nope. Okay. Your assignment's on the board, and you guys are free to work.